So in this question we saw that basically we were talking about a car which is running parallel to the train, and we just took an example of a car being at this point when the event 1 happens, and this line connecting the car and the train when the event 1 happens will be equal to will be 90 degrees, and will be at 90 degrees to the direction of motion of the car and the train, because car travels parallel to the train. Now this angle being 90 degrees is not a requirement. The only requirement is that the horizontal displacement of the car and of the train between event 1 and event 2, in fact not even the train, in fact the x coordinates of the certain when you're talking about event 1, it's the x coordinates of the front end of the train, and when you're talking about event 2, it's the x coordinates of the back end of the train. So it's these two x coordinates, and so what we are basically trying to say here is that the car should be exactly at these two x coordinates in the time difference that is there between the occurrence of these two events. So the time difference between event 1 and event 2 we know is 60 seconds. So the car should travel this much distance in 60 seconds. This distance we have calculated it is 242 meters. Now what we need to understand is that this angle need not be 90 degrees. It's just the horizontal displacement is what matters. The horizontal displacement should be equal to the difference in the x coordinates between event 1 and event 2. That is all that matters, right? This angle being 90 degrees, I've taken this as 90 degrees just for an example.